Assalamualaikum and hi again. Alright, let me now continue the process, how we're going to design a column. Firstly, you need to choose a section, and you know that the section you can choose from the table of dimension and properties. And then once you have already chosen the section, so the first step actually is to what we call classify the section, refer to clause 5.3. And why we classify the section is to avoid the local buckling to happen. As you know that from the previous lecture, there are 4 types of failure, column failure, and one of it which is difficult actually to determine, to analyze, is actually the local buckling. So if you classify the section, and then from here you classify into section element class 1, 2, 3 or 4. So once you have already classify the section, and then what you do, you follow through the formula accordingly later. So as you know that the columns are made up of 2 thin element, which is actually the outstand element and the internal element. Usually the outstand element is the flange and the internal element is the web in this case. So how you are going to specify the section, whether class 1, 2, 3 or 4. So you refer to table 5.2, and here the outstand element, and you will see that from here you refer to row section usually, because all the UKC, the one mentioned in the table of dimension properties, TDP, are all a row section. So from here you look at the what we call the limits. So if the C over T is less than 9 epsilon, and then you look at the C over T in the table of dimension properties, and then you will see that whether if it is less than 9 epsilon, then it will be class 1. If not, then it will be class 2 and so forth. So you refer to the root section part subject to bending. And for the internal element, similarly, you look at the table table 5.2, and you look at the whether it's part subject to bending or part subjected to compression or part subject to bending and compression. In this case, because there is only axial load acting on top of the column, so we just look at the part subjected to compression, and we just refer to the column in the middle here. Next, once you already classify the section, then you will use that classification on in the next step, which is step number 2, which is cross section compression resistance check. So you refer to clause 6.2.4, and then the formula you need to comply is actually the value of NED divided by NCRD, the one that I already mentioned before, and we just follow through this formula here. So which is NCRD must be greater than AFY divided by gamma m naught, where gamma m naught, you know, it is actually greater than gamma m naught is equal to 1. This is for class 1, 2 and 3, which is normally the case, right? So now the next step 3 is actually the buckling resistance check. So in the buckling resistance check, for column subjected to axial load only, you just go through clause 6.3.1 here, clause 6.3.1, where you don't have to check if it is short column. So how to check whether short column or not? You refer to this formula here. If NED over NCR is less than 0.04, then it means that it's short column. If not, the column is considered as a medium column, and you need to check the NBRD here. So the NBRD is actually the buckling resistance to uniform members in compression. So how you define NBRD? Then NBRD is actually from these two. I would avoid finding class 4 section. So NBRD equal to chi AFY divided gamma M1, that one here. So it is for class 1, 2 or 3 cross section. So to find Fy, then Fy is actually from table 3.1 here, and then you depending on the section that you chose before, then and depending on the thickness of the element, then you can find Fy from this table. And then once you have Fy, gamma M1 is actually 1.0. Next is actually to find the reduction factor chi. To find the reduction factor chi, it is coming from this formula. Where you need to know the value of phi, and phi is coming from this formula here, there. But to calculate phi, you need to know alpha and also lambda hash, lambda bar here. So to find lambda bar here, you need to know which cross section it is. So if it is class 1, 2 or 3, then lambda bar equal to AFY divided by NCR divided square root of that, where NCR actually comes from pi squared EI over LCR squared. And to get the value of E, the EI, is this value, and then LCR you get it from a table, where this table comes from this table 22 here, and LCR is actually the effective length of the compression member. If it is both its ends are rigid, then it's actually 0.7. If not, usually if the pit is 1.0. Okay. Okay. Now, once you have got the critical load, you have already got the critical load there. So, and then you have got the lambda bar there. You still need to calculate the value of alpha, and alpha, the imperfection factor alpha, actually comes from table 6.1 and 6.2. You have to refer to table 6.1 first, where it depends on the buckling. It depends on the buckling curve, whether it's buckling curve A, B, C or D. But in order to know which buckling curve here, you need to know you have to look at table 6.2. In table 6.2, so you need to know the buckling about axis, whether it is y axis or z axis. So from here, from this table, then you can refer the buckling curve. For example here, either A, B or B, C and so forth. You just choose one. It depends on this. Okay. Now once you know the table, then you can choose whether from here, then you will get the value of alpha. So from that alpha, then you can get the value of phi. From phi here, then you can get the value of chi, and then from chi, then you are able to calculate the buckling resistance NBRD here, and then you check the NBRD with the axial load, the design axial load subjected to the column, and if it is greater than NED, then your column is safe.